if you've got a terminal window open right now.
And your IDE is set to dark mode.
Yeah, exactly. If you're doing that and you're running a local AI model right on your own laptop, you are actively participating in an accidental revolution.
You really are. It's wild to think about.
Tonight's deep dive is all about tracking how a multi-billion-dollar tech monopoly was just completely upended by, well, a single leaked torrent link.
Yeah, we're looking at the history and the just massive, explosive impact of the LLaMA and open source AI revolution.
Right.
And, we're doing this because understanding exactly how we went from these massive lockdown corporate APIs to a decentralized ecosystem.
It changes everything.
It does. It completely reframes where the whole software industry is heading next.
So let's trace this back to the origin point, right? February 2023.
The dark ages.
Seriously. Up until this moment, the narrative was entirely dominated by these massive closed source models. Like if you were a developer, you could pay an API toll to interface with Frontier AI, but you couldn't own it.
No, not at all. You couldn't peek under the hood. You couldn't run it offline. And I mean, your entire application depended on a server that you just didn't control.
Which is terrifying for a dev.
Oh, absolutely.
Yeah.
But then Meta announces LLaMA.
Right, but it wasn't for everyone.
No, it was a highly capable foundation model, but it was strictly walled off. Like it was designed to be shared only with approved researchers.
You had to be on a heavily vetted list.
Exactly. You had to ask nicely.
Until someone dropped the master keys in the middle of a busy street.
That is exactly what happened.
It's crazy. A torrent link containing the model's weights just appeared on a 4chan image board.
Of all places.
Right, and then it got casually dropped into a GitHub pull request.
The contrast there is just wild to me.
Yeah, a corporate asset that took immense resources to build, suddenly circulating as a peer-to-peer download.
And for anyone listening who isn't, a machine learning engineer, when we say weights, we are talking about the actual brain of the AI, right?
Yeah, the billions of mathematical parameters that basically define its intelligence.
Right. The weights are the final crystallized result of the pre-training process.
And that process is not cheap.
Oh, to put that in perspective.
Yeah.
The barrier to entry for training a highly capable foundation model from absolute scratch is astronomical.
Yeah, you're crawling huge swaths of the public internet just to build a data set.
And then you need massive clusters of H100 GPUs.
Those ultra-expensive silicon chips.
Right, the ones that power modern AI. And you have to run them flat out. You're drawing massive amounts of electricity for months.
Wow.
I mean, we are talking tens of millions of dollars just in compute alone.
That's insane. But I'm looking at the timelines in our sources here, and I have a hard time believing the open source community was entirely dependent on Meta fumbling the bag.
Sure.
I mean, weren't there native open source efforts already happening? We had projects like Eleuther AI, we had Bloom.
Yeah, absolutely.
The community wasn't just sitting on its hands waiting for a leak, right?
Right. No. The community was incredibly active, but they were fighting gravity.
How so?
Well, the open source world simply did not have the capital to compete with the brute force scaling that the major tech labs were executing.
Yeah, that makes sense.
Like a decentralized group of volunteers can't easily crowdfund a $100 million supercomputer to run a training job for 6 months.
Right. You can't put that on a Kickstarter.
Exactly.
Yeah.
So the LLaMA leak bypassed that massive capital requirement entirely.
Because the most expensive part, that foundational pre-training, was suddenly just handed out for free?
It forced the entire industry's hand. It instantly bridged the gap between the elite AI labs and everyday developers.
In a way that, years of gradual open source development might never have achieved?
Very likely, yeah.
But, okay, a raw base model is basically just an incredibly advanced autocomplete engine, right?
Yes.
Like, if you ask it a question, it might just predict the next logical sentence instead of actually answering you.
It doesn't know it's supposed to be an assistant yet.
Right, so to turn that leaked file into an actual usable tool, developers had to teach it how to behave.
And this is what triggered the fine-tuning explosion.
Okay, let's get into that.
Within literally weeks of the leak, an entirely new ecosystem sprang up.
We see projects like Alpaca out of Stanford, Vicuna, Wizard LM, just thousands of others hitting repositories like Hugging Face.
Yeah, it was a flood.
So to use a car analogy, Meta accidentally gave away a high-end sports car engine, but Stanford Alpaca built the steering wheel, the pedals, and the dashboard so you could actually drive the thing.
That's a great way to look at it. Instruction tuning is the technical term for building that steering wheel.
Instruction tuning, got it.
Yeah. And the Stanford Alpaca team proved something truly revolutionary.
Which was?
They proved you could take this powerful but raw base model and use a relatively tiny, inexpensive data set of high-quality instructions to teach it how to be a chatbot.
Okay, but how tiny are we actually talking here?
Really small.
Because I'm imagining teaching an AI to follow instructions across thousands of different scenarios requires, like, an army of humans writing highly specific prompts and answers.
Well, here is the brilliant part. They didn't hire an army of humans.
What did they do?
They used a method called self-instruct. They utilized a larger, highly capable closed model like GPT-3 to actually generate the training data.
Oh, wow.
Yeah, they basically used the closed source giants to generate the homework for the open source underdog.
Wait. So they wrote a script that asked the commercial AI to generate thousands of examples, like write me a polite email declining a job offer, or explain quantum physics to a 5-year-old.
Exactly.
And then they fed those perfect prompt and response pairs into the leaked LLaMA model to teach it how to mimic that behavior.
That is the exact mechanism. And it worked beautifully.
That is so clever.
Right. Instead of spending $10 million to train from scratch, a researcher could spend a few $100s on cloud compute to fine-tune LLaMA.
Okay, but let's talk about the actual performance of these fine-tunes.
Sure.
Are they going toe-to-toe with the big commercial models, or are they just, good enough considering they are free?
This is a fair question.
Because there's a huge difference between a cool weekend project and a production-ready enterprise system that I would actually trust with my code base.
Well, for broad, generalized tasks, the massive closed models definitely still held a noticeable edge in early 2023.
That makes sense.
But the open source community demonstrated that you don't need a massive data center to build a highly capable system for specific tasks.
Like what?
Well, if you just need a model to write Python boilerplate, or parse complex legal documents, or maybe summarize medical records.
Right.
A fine-tuned open model wasn't just a toy. It was highly competitive at a mere fraction of the cost.
So you just needed that solid foundation and a cleverly curated set of training data.
Exactly.
That sounds like a massive win for startups trying to avoid burning through all their venture capital just on API credits.
Oh, absolutely.
But looking at the sources we have, there was still a glaring bottleneck here.
The hardware.
Yeah. Even if you had the weights and you fine-tuned them, these models were massive files.
Huge.
You needed serious, expensive VRAM, video RAM, the dedicated memory on your graphics card just to load them up into memory.
Which most people don't have.
Right. You couldn't just double-click an app on a standard laptop and start chatting.
No. And those machine learning breakthroughs wouldn't matter at all if you couldn't run the models without a dedicated server farm.
Right.
The software engineering response to this bottleneck is arguably the most critical piece of the whole puzzle.
And this brings us to Georgy Gerganov.
Yes.
And a project called LLaMA.cpp. Looking at the timeline, Gerganov essentially figured out how to cram a supercomputer-level brain onto an everyday consumer MacBook over a single weekend.
It's incredible.
Yeah.
He implemented the model's architecture in pure C and C++C, which just drastically reduced the software overhead.
So no bloated Python wrappers.
Exactly. But the real engineering magic here and the concept that fundamentally changed the landscape is quantization.
Quantization. This is basically the MP3 compression moment for AI, right?
That is the perfect analogy.
Like, we took these massive, unwieldy, uncompressed audio files, or in this case, neural networks, and compressed them so they could run on consumer hardware. But I need to understand the mechanics here. When we crush these massive models down to fit on a laptop or a phone, how much of the model's actual intelligence are we sacrificing?
It's a valid concern.
I mean, you can't just delete half the data and expect it to be as smart, right?
It seems totally counterintuitive, but it comes down to how neural networks actually store information.
Okay, break that down for me.
Usually, models are trained using 16-bit floating point numbers.
Right.
That offers a very high degree of mathematical precision for every single weight in the network.
Right.
Quantization tools like LLaMA.cpp compress those numbers down to 8-bit or even 4-bit integers.
Wait, so the resolution of the math gets blurrier?
Yeah.
Instead of knowing a value is exactly, say, 3.14159, the model just rounds it and knows it's roughly 3.
Exactly. And neural networks are surprisingly resilient to this loss of precision.
Really?
Yeah. The intelligence isn't stored in the exact, perfectly precise value of a single parameter. It is distributed across billions of connections, all working in concert.
Oh,
Think of it like watching a 4K movie versus a 720p stream.
Okay.
You lose some crispness in the background details, sure,
Yeah.
but the plot of the movie, the dialogue, the core experience is exactly the same.
That makes perfect sense. So when you quantize model down to 4-bit, it might hallucinate a tiny bit more, or its vocabulary might become slightly less flowery,
Right.
but the core reasoning, the logic, largely remains intact.
Exactly. You trade a microscopic amount of performance for a massive, massive gain in accessibility.
Wow.
Efficient inference removed the cloud compute bottleneck entirely.
Because before this, running a capable language model meant you were completely tethered to the cloud,
You were sending your data to someone else's server,
relying on their uptime.
paying their compute fees.
Yeah.
Suddenly, you could run an assistant locally, completely offline, with total privacy,
It distributed AI capability directly from the data center to the individual.
which completely shifts the center of gravity in the tech world.
It really does. Because once the community had the tools to run models locally, the natural next step was building smarter, highly optimized base models from scratch.
Designed specifically to maximize that local hardware.
Right. We didn't just stop at compressing Meta's leaked model.
No, the open source movement matured from merely reacting to a leak to actively driving architectural innovation.
And the sources highlight a wave of new players here, specifically Mistral and DeepSeek.
Yes, very important players.
And the geography of that stands out immediately to me. Mistral is based in France. DeepSeek is out of China. This proves that open source AI leadership is a truly global phenomenon, completely breaking out of the Silicon Valley bubble.
It absolutely is. And what Mistral and DeepSeek brought to the table was a focus on brains over brawn.
Okay, I like that phrase.
Because the biggest commercial labs were engaged in a massive arms race, throwing tens of thousands of GPUs at increasingly massive data sets in a pure contest of scale.
Right, just brute force.
Yeah. These global open source teams took a step back and looked at architectural elegance.
But how did they actually compete with less compute? You read about Mistral outperforming models twice its size.
Right.
Or DeepSeek training a frontier-level model at a fraction of the cost. What's the actual mechanism there?
Well, one of the primary mechanisms is a concept called mixture of experts, or MOE.
Mixture of experts. Okay, let's look at how Mistral actually achieves its efficiency with that.
In a standard, dense neural network, every single time you generate a word, the entire model activates.
So if it's a 70 billion parameter model,
All 70 billion parameters are doing math for every single token you generate.
which takes massive amounts of memory and processing power, dragging everything down.
Exactly. With mixture of experts, the model is divided into specialized subnetworks, the experts. When you feed it a prompt, a routing network acts kind of like a triage nurse at a hospital.
Oh, that's interesting.
Yeah, it looks at the request and says, oh, this is a math question, send it to the math expert. Or this is French translation, wrote it to the language expert.
Ah, so instead of waking up the entire massive brain, it only activates the specific subsections needed for that specific concept.
Exactly. So a model might have 50 billion parameters in total, but it only actively uses, say, 12 billion parameters for any given word.
Wow.
You get the intelligence and capacity of a massive model with the speed and efficiency of a tiny one.
That is brilliant. Does this mean the era of just throwing more GPUs and brute force compute at a problem is officially over? Like, have we hit the wall on scaling?
Well, I wouldn't go that far. Scaling still yields incredible results, and the massive labs are definitely still pushing those boundaries.
Yeah.
But Mistral and DeepSeek proved that scaling is no longer the only vector for progress. AI is becoming a precise engineering discipline. You can win with better data curation pipelines, sharper architectural design, more elegant mathematics.
You don't necessarily need the biggest computing cluster in the world to push the frontier forward.
Exactly.
And because these highly optimized, incredibly powerful models can now run locally anywhere in the world, we inevitably crash right into the defining philosophical and practical clash of our time.
The great debate between openness and safety.
Yeah. It is the most complex tension in the entire industry right now.
It really is, and both perspectives are grounded in very real, very pressing concerns.
Absolutely. Because if you are building an app right now, this safety debate isn't just philosophical.
No, not at all.
It dictates whether the API you rely on might suddenly get nerfed tomorrow.
Exactly.
Which is exactly why a developer might want to switch to an open weight model they can control. I mean, if we lock down models in the name of safety, don't we kill the exact reproducibility and transparency that developers rely on to build reliable tech?
Let's look at why developers inherently value looking under the hood. If you are building enterprise software, Relying on a closed API is a massive structural risk.
Right, because the provider can change the model overnight.
Yeah, breaking your application's carefully crafted prompts. They can alter the alignment, change the pricing structure, or even deprecate the model entirely.
It's the same reason open source software like Linux won the server market. You need to know what code is actually running on your machine.
And you need to know no one can take it away from you.
Exactly.
Open weights enable that crucial transparency. You can inspect the model, you can reproduce research results, and you can audit it for vulnerabilities.
It guarantees a level of scientific rigor that black box commercial models simply cannot offer.
That's the open source argument. However, a language model is not just a standard piece of code.
Right. It's not a JavaScript library you import to build a website.
No. We have to validate the complex reality of releasing frontier capabilities into the wild without guardrails.
Yeah, that is the flip side.
As these systems become more capable at complex coding, advanced reasoning, and potentially assisting in areas like cybersecurity or synthetic biology,
The stakes go way up.
the safety argument becomes increasingly salient. When a model is open-sourced, the creator fundamentally loses the ability to revoke access if a critical vulnerability or a dangerous capability is found later on.
Right, you cannot patch a set of weights that has been downloaded a million times and is sitting on hard drives all over the world.
Exactly. The safety perspective argues that releasing highly advanced, unfiltered models into the wild presents asymmetrical risks that our current digital infrastructure just isn't prepared for.
It's a debate over who gets to hold the keys to a potentially world-altering technology.
It really is.
It's a heavy debate,
Yeah.
and it's one that certainly isn't going to be resolved tonight. But it's fascinating to see how a single event forced this conversation out of academic circles and right onto the laptop of every developer in the world.
It completely democratized the conversation.
We've traced quite the journey today. We went from that catalytic leaked meta model in February 2023
The spark.
to the Cambrian explosion of fine-tuning, where the community built out custom steering wheels and instruction sets using clever workarounds like self-instruct.
And then we explored the engineering magic of quantization.
Right, how tools like LLaMA.cpp crammed supercomputer models into everyday hardware by compressing the mathematical precision.
And we watched as global teams like Mistral and DeepSeek utilized innovations like mixture of experts to prove that architectural elegance could challenge brute force scale.
Which sets the stage perfectly for where the industry is heading next. Because the open source revolution didn't just create its own ecosystem, it fundamentally altered how the commercial giants have to operate.
Well, they had to adapt.
Tomorrow, we are going to survey the full competitive landscape of the 2025 to 2026 model wars.
That's going to be a good one.
We'll be looking at Claude, Gemini, Grok, and dozens of other models to see where the industry is converging, what really differentiates them, and whether we are going to end up with a single monolithic winner or a diverse, thriving ecosystem.
It's going to be a crucial look at how the commercial side has adapted to the sheer pressure of the open source movement.
Before you switch back to your terminal window and get back to your code, let's leave you with a final thought to mull over. We've talked about how this revolution was sparked by a static, leaked model in 2023.
Right.
But hardware is getting better and the algorithms are getting leaner. If a single leaked model was enough to spark a global engineering revolution that decentralized AI, what happens when tomorrow's open source models are natively designed to train and improve themselves on the billions of everyday devices we already have in our pockets? We'll see you on the next Deep Dive.